Kenneth Velasquez, and for this episode, we are going to talk about related grades, and I am going to show you how to solve a problem. So first, what is related rates? So related rates is the relationship among variables that varies with time. Looking back to my previous episode, as I was scrolling down to the comment section below, a subscriber asked me to solve a problem about a cone that is related to the related rates. So the problem goes like this. So the problem is, assume that sand allowed to pour onto a level surface will form a pile in the shape of a cone with height equal to the diameter of the base. If sand is poured at 2 cubic meters per second, so the problem is, how fast is the height of the pile increasing when the base is 8 meters in diameter? So let us now start. So this is the illustration of the problem. The problem states that the height is equal to the diameter of the base, and the base is 8 meters in diameter. So the base is 8 meters and also the height is 8 meters. So the diameter of the base and the height has the same value. So this is the formula for solving the cone in order to find the final answer of the problem. So V is equals to pi over 3 times r squared times height. So the V here represents the volume of the cone, and the r here represents the radius with the exponent 2, and the h here represents the height of the cone. So these are the given values of the problem. So h is equals to diameter because the problem states that height equal to diameter of the base. So we all know that the diameter is twice the radius. So h is equals to 2r. So in order to find the value for r, we will transpose 2 in the h. So the result will look like this. H over 2 is equals to r. So we have now the value for r. So the problem is, if the sand is poured at 2 cubic meters per second, so now this is the rate of change of the volume with respect to time. So dV over dt is equals to 2 cubic meters per second. And the unknown value of the problem is, how fast is this height of the pile increasing when the base is 8 meters in diameter? So this is the rate of change of the height with respect to the time. So the problem also stated that the height of the pile increasing when the base is 8 meters in diameter and the height equal to diameter of the base. So the base and the height have the same value. So now the given values of the problem are stated, so we can now solve. So this is the solution. So the formula for the cone is volume is equals to pi over 3 times r squared times height. So r is to radius and h is to height. So let us now substitute the given values to the formula. So volume is equals to pi over 3, then substitute the radius because the radius is equals to h over 2, so let us now substitute. So h over 2 squared times height. So h over 2 squared, let us now distribute the exponent. So h squared over 2 squared is equals to 4. So V is equals to pi over 3 h squared over 4 times height. So we will now multiply h squared over 4 times height. So the h here has the exponent 1, so h squared times h is equals to h2 plus 1 is h3 over 4. So v is equals to pi over 3 times the quantity of h cubed over 4. So here we will use the multiplication rule. So we are going to separate the pi and the h cube. So we are going to separate it with the multiplication sign. So pi times h cube over 12. So in this portion, we will be going to use the implicit differentiation. So we are going to derive h cube. So how to derive h cube? So first, identify the exponent. So the exponent here is cube. So move the exponent as a whole number. So 3. Now, subtract it with 1. So 3 minus 1 is equals to 2. So 3h squared is the derivation of h cubed. So now, volume is equals to pi times 3h squared over 12 with respect to the time. So this is the implicit differentiation. And all the variables respect to time. So now, the rate of change of the volume with respect to time, or the dV over dt, is 2. So let us now substitute the given values. So dV over dt is equals to pi times 3h squared over 12 dH over dt, so with respect to time. So dV over dt is 2, and let us now substitute h, and the height is 8. So 2 is equals to pi times 3 times 8 squared is equals to 12 with respect to time. So now, in order to find the rate of change of the height, or the unknown value with respect to time, let us use the multiplication, or the cross multiplication rule rather. So 12 times 2 is equals to 24, and the result of 8 squared is equals to 64. So let us use the multiplication, the cross multiplication. So 12 times 2 is equals to 24, and pi times 3, 8 squared is equals to pi times 3 times 64. So 3 times 64 is equals to 192. So 24 over 192 is 1 over 8 pi. So this is the final answer, and this is the unknown value. So 1.8 pi is the rate of change of the height with respect to time, and when the base is 8 meters. So this is the final answer.